Hello, my name is Yuti Shah and we are group number 1. My teammates are Niket Vanya and Rushabh Khara. The topic for our presentation is radio frequency identifier based authentication. Our table of contents, which includes introduction or overview of RFID technology, brief working of RFID, applications, advantages and disadvantages, examples and references. Our introduction now. Radio frequency identification, which is also called as RFID, is a wireless technology that can be used to develop the access control system. This presentation will showcase the use of this technology to automate various processes ranging from industrial sector to home control. Automotive identification and access control system has become necessary to overcome the security threats faced by many organizations all over the world. By installing the system at the entrance will only allow the authorized persons to enter the organization. The system can also be installed at various points inside the organization to track the person's movement and to restrict their access to sensitive areas in the organization. In such a way, suspicious persons can be caught, which will surely improve the security level in the organization. Overview of RFID technology. Tagging items with RFID tags allows user to automatically and uniquely identify and track inventory and assets. RFID takes Auto ID technology to the next level by allowing tags to be read without line of sight and, depending on the types of RFID, having a read range between a few centimeters to over 20 plus meters. RFID has come a long way from its first application of identifying airplanes as friend or foe in World War II. Not only does the technology continue to improve year over year, but the cost of implementing and using an RFID system continues to decrease, making RFID more cost effective and efficient.
You, Yuti, for your explanation. So I'll be taking over from here. I'll be going with the working of RFID. RFID system consists of mainly three components. There are transponder, which is called tag, the interrogator, which is called reader, and the computer containing the databases. You can see in the below figure. The interrogator reads the tag data and transmit it to the computer for authentication. The information is processed and upon verification, access is granted. The system offers diverse frequency band ranging from low frequencies to microwave frequencies. The low frequency is set from 125 to 134 kHz. High frequency is 13.56 MHz. Ultra high frequency is 902 to 928 MHz, and microwave frequency is 2.4 GHz. So depending upon the source of electrical energy, RFID tags are classified as either active or passive. The active tags use a battery for powering the circuit on the tag and transmit the tag information upon the reader request. However, these tags are very expensive and seldom used. On the other hand, the passive tags get energy from reader to power the circuit. These tags are very cost effective and hence most of the applications use them. Passive RFID tag transmit information to the reader when it comes in the vicinity of electromagnetic field generated by the reader. The current flowing through the coil of interrogator produces a magnetic field which link to the tag's coil, thereby producing a current in the tag coil. The tag coil then varies the current by changing the load on its antenna. The variation is actually the modulated signal. This scheme is known as load modulation, which is received by the reader coil through mutual induction between the coils. The reader coil decodes the signal and passes to the computer for further processing. So these are some basic applications where RFID is majorly used. So the first one is healthcare. RFID application in healthcare could save important resources that can further contribute to patients' care. Then security and control, inventory management, supply chain, and package tracking. Like RFID application provide best resource management, effective operation, and efficient transfer of packages. And nowadays, you have seen vehicle tracking on toll road using RFID tags. Look into the advantages. So first one is reduces the manpower, improved data accuracy and availability because data is being collected and uploaded electronically, saving time and money through automation. RFID applications can automatically track the movement of goods and upload the information to the ERP or financial management system. The fourth one is high speed for data processing. The next one is better control of production. And the last one is multiple tags reading at once. We'll look into the disadvantages. The first one is it is costly because it requires battery replacement if the tag is active. The second one is privacy. Privacy is a concern with the use of RFID on products as it can be easily tapped or intercepted. The third is electromagnetic interference from some materials. The fourth is limited RFID coverage range. And the fifth one is overloaded reading, which is fail to read.
Here. So I'm going to give you the examples of RFID based authentication systems. First, we have RFID door access system, and that falls under the security access control category. So here is the proposed scheme, and I'm going to tell a brief about what it does. So RFID readers are installed at the entrance of the hostel, and that detects uh, the RFID tag. The system captures the user image and scans the database for a match. If both the card and captured image belongs to a registered user, then and then access is granted. Otherwise, the system turns on the alarm and makes an emergency call to the security van through GSM modem. In this way, the suspicious persons can be caught. So I will explain you the flowchart of the entrance monitoring system. First, whenever a user is presented at the door, and they're gonna scan the RFID tags. So if the tags are detected and those are RFIDs enlisted in the database, then the system will uh, take a picture, save it, and it will match against the database. So if the user is registered user, then it will process the further. Otherwise, it will block the RFID and place a fine on user. And on the first step, like if the RFID is not listed, then also system will capture the image and make an alarm and security call. So going further, after the user is registered, it will check if the status is like false or not. Suppose if status is false, then that means that the user has never entered, so someone else must be there. So it also do this and blocks the RFID and places a heavy fine. Now there comes the RFID status is also true. Then we'll go to the status defaulter, and if the defaulter is false, then it will place like a defaulter on the LCD screen. And if the defaulter is not true, it true, then the entrance door will be opened and the timestamp will be recorded into database, like when this person is entered the premises. The same goes with the exit monitoring mode. Whenever they have to scan their RFID tags at the exit, and at this like just the same as the entry monitoring system, the system will take a picture and save it, and it will check against the database if that RFID is listed in the database or not. Suppose if database in the database RFID entry is not there, then they will check again. They'll make an emergency call. Otherwise, they will open the exit door, and it will again record the timestamp and update the exit status. So this was the monitoring section. Now I will tell you about the authentication system. So here the security and access control system is comprised of two phases, like registration and recognition. In the registration phase, 10 images of a hostile user, those are captured while issuing the RFID tags, and the images are used to train a neural network with a backpropagation algorithm, and the converted weights are stored according to a particular user. During the recognition phase, the user wants to enter into a hostel. At this point, after getting the RFID user number, an image of a user is captured and passed to a neural network for recognition. If a match is found, then access is granted to the user. Now, user authenticity is checked at two places, like hostel entrance and exit, and both the entrance and exit modules use RFID face recognition. These modules communicate with computer system through a main controller, and controller transmits the information to a system, that's a backend database. And the computer system, after processing these interrupts, issues a command to modules through the main controller. That's when the gates are open. So this was the one system. Now, this is another system. It's a pseudo random number generator, and that falls under the category of wireless communication. I'll tell you brief about the system. So here the authentication scheme, which uses a pseudo random number generator and some simple cryptographic operations. Here the current generation of RFID tags comes with inbuilt pseudo random number generators, and implementation of those operations are possible with low complexity. The secret information stored inside tags are communicated in a more secure way, ensuring confidentiality, integrity, and authentication. Now I'll talk about the notations that are used in the diagram. The SID means that secret ID and synonym of tag. S new and S old, those are current and previous session secret of tag stored in the backend server. H, that's H, and H is a one-way hash function. PRNG, A, that's a pseudo random number generator to find a random number with A as a seed value. And PRNG AB, AB means a pseudo random number generator to find a pseudo random number B with A as a seed value. Double pipe means the function acts as a string concatenation, and the circle outside the plus symbol is XOR operator. So here there are basically three steps happen. A reader generates a random number with random number NR and sends it to our tag, and after the receiver after the tag receives the NR number from the receiver, it will generate again a random number that's empty, and it will calculate the V. So V means a value. So the V takes input, V basically counts a pseudo random number generator with seed value and those two random numbers, and at the same time hash of the ID is also calculated using the information that's stored in this tag. Then all of this information tag sends to a reader, and reader forwards those information to a server along with the random number generated by reader. After that, server receives those values, and it retrieves the database records of the hash of the ID, and it will find if the record is corresponding to the hash that we just calculated. So there are three possibilities. If no record is there, and that's not the same value, the communication is clearly terminated and access is not granted. If a record is found, the server extracts the corresponding tag secret seed from a database and calculates the new V dash. V dash means that's a pseudo random number generator function used with the new seed value and the two random numbers that are generated by tag reader and tags respectively. And this V dash will be verified And if the value of v and v dash both are equal, then it confirms that previous session was successful, and now tag contains new value, that's a new seed value, as new instead of the original as, and server sends this as new to the reader. And there's one more possibility: if v and v dash are not equal, server extracts the old seed value of the corresponding match tag and calculate v double dash. If v double dash and v are equal, and if this equality holds, then it makes the flag, then it makes the variable flag 1 and sends the old seed value to a reader. His reader is confirmed about the unsuccessful previous session, and tag contains an old seed value instead of new. At the fourth place, the reader takes the value either as new or as old as per the seed from the server and calculates the m. M is used to find m as a seed value. It calculates the random number n from the random number generator function. A reader sends this n value tag and m to a backend server. Here, modulo operation can be used to make NR to make it less complex for calculations, and same must be done at the tag side also. And to confirm the reader is authenticated, a tag calculates dash, that's an rth pseudo random number, by taking the as that's a seed secret stored in the tag and as the initial seed value. Now using m dash as a seed value, it calculates a new random number. The tag verifies if n dash and n are same. The tag is confirmed that information is from legitimate reader. Now the tag calculates a u. U is using h, so it's gonna take a hash format, old seed value and the m dash, and it's gonna take the hash of it and updates the secret value, and then again it will do an XOR operation. Now after server gets all this information, and it will check against the m value and to check against the reader if the flag is a variable or not. And flag variable, suppose if it's 0, then the secrets of the tag is matched with the new seed value. And again the server calculates u, so it's gonna take a hash of it, but instead of the old seed value, it's new seed value, and again it will update the secret values in the database. So the old seed value will contain a new seed value, and a new seed value will contain a new seed value, and along with the XOR operation. And for the second possibility, if the flag is 1, the secret of a tag has matched with the s old value and calculates u, so that's a hash of s old and concatenation with ham. The server updates the secret value in database as s new and s old, as s new will contain the s old plus XOR u, and s old remains unchanged. So these are like 4, 5, 6 steps. Include, I will say that RFID based security system is simple, user friendly, reliable, and has more secure control to your valuable property. It is also more secure and fast compared to conventional system. These are the references that we have used to make this presentation, and thank you for your time.